you're familiar with graphing square roots, graphing cube roots is going to be relatively easy for you. As a matter of fact, you'll find it to be a bit easier. We can get an idea of the basic shape here. And what I have is a table where I want to find the cube root of these values. Now, first of all, what is a cube root? Well, a cube root would be the value of the variable when multiplied by itself 3 times makes the requested number. As an example, what times itself 3 times makes negative 8? And I'm going to think about it for a minute, but it's going to be negative 2. And the reason that is, if I take negative 2 and I multiply it by itself 3 times, it's going to be negative 8. 2 times 2 times 2 is 8. And since I have an odd amount of negatives, negative times negative makes a positive. Well, I multiply that positive by the remaining negative, you're going to get negative 8. So the cube root of negative 8, going backwards, the cube root of negative 8 is negative 2. Similarly, what times itself 3 times makes negative 1? It's going to be negative 1. What times itself 3 times makes 0? 0. Times itself 3 times makes 1? Positive 1. What times itself 3 times makes 8? 2. So this is called the cube root. Notice we put the little 3 here. That 3 is called an index here. And when we want the radical sign, which is this, what people call a square root sign, when we want it to not be a square root, to be some other root, we put a number there, and that number is called the index. Just a vocabulary mention there for you. If I graph this, I'm going to start by graphing the middle 3. Negative 1 is here, 0, 0 is here, and then 1, 1 is here. It looks like a straight line as it is now. The other 2 points, 8, 2, I don't have room to graph it, or I didn't carry it out that far. I'm just estimating its location. It's going to be well over to the right here. 8 over, which I'm estimating. It's not twice as far as what you see. And then 2 up. And notice now that it's not a straight line. Similarly, on the other side, if I go negative 8 and down 2, it'll be into my table here. If I get this curved shape, it does resemble the square root graph if I were just to look at one side of it. Now, it is a little bit flatter than the square root graph, but the big difference you notice is it's not just one sided, it's 2-sided. And the reason for that is the 3. With an odd index, negatives are now allowed. You can go this way because I can take the cube root of a negative number, due again to this fact that when I multiply negative times itself an odd amount of times, you can pair up all these negatives, but you're always going to have that one extra that would make the end result be negative. So I can take the cube root of a negative and get a negative. And that's going to make our domain and range here much easier. Not much easier. The square root wasn't really hard, but it's going to make it, without even thought here, this goes to the left forever, this goes to the right forever. So when we say the domain is all real numbers, or in interval notation, negative infinity to positive infinity. Remember, infinities are not numbers, they're ideas, so you can't put a bracket here. Range is going to go down forever, it's going to go up forever. So it's going to also be negative infinity, positive infinity. There's no exceptions to that. Domain and range, negative infinity to positive infinity for both. We have y equals the cube root of x minus 2 plus 3. Like before, it's still helpful to write out that point 2, 3 here. It's not going to show up in the domain and range now, but it still helps me locate it. 2, 3 would be over 2, up 3. Instead of being the point of origin now, this is going to be the middle point, what later you're going to call a point of inflection. That is part to where it's right in the middle, to where one way goes this way, the other goes like this. If I go over 1, up 1, and I want over 1, it's going to curve into that point and be rather sharp. There's no asymptotes here for cube root graphs, but it begins to resemble an asymptote from before. But there is no horizontal asymptote here, it just kind of gets flat there. But that's it. 2, 3 is the point in the middle that you can get again by changing the sign here and not here. My domain and range, you don't even have to think about it here. Negative infinity to positive infinity. And that's it. y equals -4 times the cube root of x minus 1. Again, the point in the middle here, change the sign. There's nothing you're adding on the outside, so it's a 0. So 1, 0 is my point in the middle for this one. And we added a little bit more to it here, or didn't add, maybe not be the best word to use, but we're multiplying a 4, and we have this negative. So a couple things are going to happen. The 4, if you'll remember, is going to stretch it out a bit, and the negative is going to flip it upside down. Well, flip it upside down would be, instead of curving up like this, it's going to now curve down, right? And then go like this. Now, exactly how far we go, if I go over 1 now, it would actually go about 4 now. It's going to curve rather drastically due to that 4. Same thing here, I'm going to kind of go up like this. And notice, again, I'm being pretty approximate with it. I could get a graphing calculator out, which you can download on your phone or look up on the internet and punch this in, and you're going to see a shape very, very close to what I have. The negative, turn it backwards, the 4 stretched it out a bit, but it has the same shape. And even though we have the negative and the new orientation just means direction that it's going, it does not affect the domain range. I'm still left forever, right forever, I'm still down forever, up forever. So unlike the square root graphs, you're never going to change anything on domain and range here. You can put whatever you want into the function, you can get whatever out of the function that you want.